Hi guys, this is Musa. In this video I'm gonna explain the homework 2 problem 1. So we're gonna define decision variables. In the homework sheet I'm saying that please name your decision variables as C, D, T, W. So as we discussed in the money problem, the similar idea, we're gonna say that our decision variables will be the number of units for chairs, desks, tables, and wardrobes. So our decision variables are this: the number of units for each furniture type. Okay. Then we're gonna calculate the unit profits for each furniture type. So I have selling prices and I have resource usage for each furniture type. Also I know the cost of each resource usage. So I'm gonna do the following. So for the unit profit of chairs, I'm gonna use its selling price minus what is the resource requirement for chairs. Those numbers, I mean those are the numbers for cutting, sanding, finishing, and wood, and those are the resource requirements. Okay, so by using these numbers I'm gonna do the sum product. I'm gonna do sum product, these numbers, comma, resource cost. But I wanna break down my formula. Why? Because I also want to calculate the unit profits of D, T, W, and each time I will be using different resource usage data, but I'm gonna use the same cost information. So that's why I need to fix the cost row, for which I'm gonna press F4 and observe the dollar signs. Again, why I am doing this? Because I want to drag down the formula. When I drag down this formula, I want this resource cost as a fixed, but the other resource usage rows should be changing when I drag down. Okay, so selling price minus resource cost times the resource usage for each chair will give us the unit profit. So when I drag down the formula, I have dollar signs. This is what? This is the unit profit for D. As you can see, the dollar sign range is fixed, but the resource usage for this desk is now calculating the corresponding desk row resource usage. For this one, the idea is the same. For this one, the idea is the same. So I am not using dollar sign for the red range. That's why it's changing when I drag down. But the range with the dollar sign does not change. This is the idea of fixing. Okay, what is the objective function? It says you can use those unit profit to express your objective function. So in the problem, the company wants to maximize its total profit. So my decision variables are C, D, T, W, and I also know the unit profit. So I'm gonna just write maximize unit profits time my decision variables, the unknown numbers. That's it. My unit profits and my decision variables. Okay. What about resource constraints? So I have 1, 2, 3, 4 resources. So for each resource we have some available units which are given in the problem, and for each furniture type, for each resource for each resource I'm gonna use that resource in chairs, desks, tables, and wardrobes. Okay, so for instance, for this cutting, I'm gonna use these numbers that are the resource usage of that resource. Okay, so by using those numbers, for instance, for this one, I'm going to use 1, 2, 2, 3, and I multiply these numbers with the decision variables C, D, T, W. This is what? This is the resource usage for cutting. Okay, and in the problem it's given that the available resource labor hours for cutting is 800. That's why when I sum product my decision variables with the resource usage, the left hand side should be less than or equal to its available amount. So for this one, the idea is the same. I'm going to use this numbers 1, 2, 1, 3, 1, and I'm going to sum product with them with the decision variables. Okay, and I put the available units to the right. For the last one, the idea is the same. 6, 10, 8, 12. I multiply those numbers with my decision variables C, D, T, W, which will be the resource usage in the optimal solution, and that resource usage cannot exceed the available root capacity. Okay. What about market constraints? In the question, it is given that we have some direct upper bounds on the number of units that needs to be produced. So I cannot produce more than 300 for chairs and 100 for desks, 150 for tables, and 100 for wardrobes. So as you can see, these are market constraints. So I'm writing my decision variable C less than or equal to 300. So the idea is the same for all the other constraints. Also, to make sure that we don't have any negative numbers in the optimal solution, we are always including those non-negativity constraints. Okay. So thanks for watching.